let's focus on a VMware instance of Red Hat Enterprise Linux. The way we'll achieve it is by setting up the VMware environment and then installing Red Hat Enterprise Linux. Let's log in as a user who has access to the VMware instances, user root, and once we have our desktop, we'll launch the icon which leads us to VMware. As you can see, we've got the Red Hat Enterprise Linux DVD inserted into the drive. This DVD has all of the software you'll find on CDs 1 through 5. Here's the VMware Server Console icon. We've created this many versions of Linux CBT ago, and this particular system happens to be that machine, that SUSE Enterprise machine we mentioned, which functions as a VMware server. VMware is a hot topic because it allows administrators and data center maintainers to make full or take full advantage of unused CPU and other hardware resources. Let's launch VMware Server Console. Now we need to allocate space and resources for this new instance. We've connected to the local host and we've closed the window where we have our other instances, but if we click on inventory, we'll see the list of other VMware hosts. We've got XP, FreeBSD, Solaris, and Debian. But we don't need the inventory window at this stage. We do need to create a new virtual machine. Now on the system we have a hard drive dedicated to housing virtual servers. The df-h will show that we have a mount point named VMware 1 located off of the root of the file system, and it is a hard drive that's about 500 gigabytes with about 101 gigabytes free. So we can allocate, let's say, 25 gigabytes for Red Hat Enterprise out of this space. Beneath VMware 1, we'll find multiple subdirectories, including Linux CBT, which is used to store other information, but more importantly, the virtual machines subdirectory, which contains one directory per item in our inventory. For example, for Debian 4X, you'll see all of the files that represent the file system, configuration options, and so on. So when we set up an environment for this Red Hat Enterprise VMware installation, a similar subdirectory structure will be created with files that have a prefix of the name of the inventory item. And these files are used for different reasons, for file systems, options, and so on. All managed by VMware, of course. Now, this is a pretty powerful system. It has multiple CPUs. A cat proc CPU info will reveal those multiple CPUs, 2.6 gigahertz CPUs, that are largely unused. And uptime will give us a sense as for the utilization for 1, 5, and 15 minutes, and it's usually low. Top will tell us what the current utilization is like, and again, it's pretty low. With that said, let's clear screen, return to the VMware Server Console, and create our environment. We'll create a new virtual environment, new virtual machine environment that is, and we want to designate one of our distinct NICs. By the way, if we just go to View Inventory and look at the Debian setup, for example, this Debian setup has all of the options that we need for our new Red Hat setup, such as the Ethernet, mouse, processors, so on and so forth. So we can dedicate 2 processors. It will automatically detect the mouse, and we'll use Dev VMNet 2 as a network interface. This is a dedicated interface for our Linux instances. The Debian instance, as you can see, has pre-allocated space of 50 plus 10 plus 10 plus 10, so 80 gigabytes of storage. It also has access to the CD-ROM drive, which doubles as a DVD-ROM drive. And we've allocated 512 megs of memory. This system, if we execute free-m, which is another Linux utility, has about 2.5 gigabytes worth of memory. So we can allocate as much as we'd like up to that point, or up to and close to that point, that is, leaving some for the host operating system. Again, VMware is separate from Xen or other virtualization technologies. This is a third-party product, which is all the rave. So we don't want to power on the Debian 4X instance. We'll close it. We don't want to actually see the inventory window. We want to be able to create a new instance for usage across the board. Navigate to Quick Switch, it turns off the interface so that we see less of the interface. Double click up top, it turns it off. Basically makes it available on a pop-out basis. Now we want to create a new host, so we'll go to File, New, Virtual Machine, and then a wizard pops up. This wizard allows us to specify the applicable properties of the system. This is a typical system. It isn't custom, so we'll go ahead and select typical. It's a Linux system. However, VMware supports multiple other OSs. When you select Linux, it defaults to Red Hat Linux. You can also indicate a version of Enterprise Linux. We'll select 4 as it's the closest. This version also supports 64-bit OSs. However, in order for 64-bit OSs to be supported, your host operating system should be 64-bit as well, so you should match them up. Otherwise, even if you're able to get it to work, you'll only obtain a high level of emulation, which could hinder performance. So if you want to support 64-bit base VMware hosts, then ensure that the host system is running a 64-bit version of Linux or whatever other operating system you are using to host. So we'll go ahead and indicate Red Hat Enterprise Linux 4 version 5 hasn't been included into this version of VMware Server. But for our intents and purposes, Enterprise Linux 4 will work. We'll change it from Enterprise Linux 4 to 5. And by the way, this is only a suggested name. You can call it whatever you'd like, such as RH5 Instance 1. So long as you name it something consistent, the VMware wizard will create a subdirectory beneath VMware 1 virtual machines, followed by the name of the instance. Additionally, you can place your instance anywhere you'd like on your computer. So it doesn't have to be beneath that VMware 1 partition that we pointed out in the shell. But for our intents and purposes, it works because this is the mount point, which leads to a hard drive that has ample storage. However, if we have storage elsewhere in the system, such as on a root file system, and if we have enough available storage, we can use the optional mount point as well. So you can store it anywhere you'd like. We've just decided to store our operating system guests on distinct partitions, distinct mount points, or beneath a distinct mount point in distinct directories. Let's click on Next. Whether or not you want to use bridged networking, which makes use of your default network interface used by the host system, or use network address translation, use host-only networking, which means networking is only local within the host, or if you don't want networking to be enabled. Bridge networking is the option which allows you to select an interface and bridge connectivity. Disk size. How much space should be provisioned? Now, as you saw before, we utilized 2.5 gigabytes for our Red Hat Enterprise installation. So if we specify 8 gigabytes, this should be more than enough. By default, VMware splits the storage into 2 gigabyte sizes. If you create 100 gigabytes of storage, it'll create 52 gigabyte size files to increase performance. The disk space will be allocated now. And we'll click on Finish, and that's what will take a little time. 8 gigs doesn't take that much time, but a little time to allocate. And we'll have it available to us momentarily. So again, VMware provides virtualization. It creates a container within an operating system environment to house other guest operating systems of various types, as well as of various platform types, such as 64-bit versus 32-bit. If you have 64-bit, you can host 32-bit OSs. Usually you cannot the other way around, unless, of course, there are patches or modifications to the VMware software which permits it. In any case, you probably wouldn't want to, as it would hinder performance. So the 8 gigabytes of storage is being created. Now, from a file system perspective, if we navigate back to VMware 1, virtual machines, we'll see that a new directory has been created named after the instance that we defined. And there we see the various items. RH5 instance, VMDK, these are virtual disk drives that are being used by VMware. As mentioned, they're split across 2 gigabyte files, so each of these files will occupy 2 gigabytes of storage, and as we can see, the third one's being created. It's roughly over a gigabyte right now. LSLTRH will tell us that it's at 1.4. When it reaches 2 gigabytes, then the fourth and final file will be created, and we'll be nearing the end of the create disk process. So as you can see, we're at 80-something%, and that fourth file is already at 603 megabytes. It moves very quickly. So these are the disk files that will constitute the hard drives or drive or the hard drive that's seen by the guest operating system. So when we install Red Hat Enterprise Linux, VMware will present this block of 2 gigabyte storage files as contiguous space. So the operating system will believe the 4 2 gigabyte files to be one 8 gigabyte hard drive. So now we've got our settings for this Red Hat Enterprise system. The Ethernet 1 is bridged. As we mentioned, we wanted this option to be tied to VMnet 2, that is. So we'll just go to Custom Specific Virtual Network, VMnet 2. We know this because when we set up the VMware software, we indicated that VMnet 2 would point to a specific Ethernet interface, as this system has multiple interfaces. So we want all of our bridged interfaces, or all of our interfaces, to route to specific virtual networks. Let's click on OK. We'll move this into focus, and we should be fine. And we'll scroll down towards the bottom, and now it's set to use dev VMnet 2. This is optional. If you select bridge or NAT, the primary interface will be used, but from the shell, if we specify ifconfig, you'll see the interfaces that are available. Ifconfig-A shows all of the interfaces that are available. VMnet 2 is tied to one of the interfaces that we'd like to use. So the memory will be 256 megs. This can be upped as well. The specifications for memory are indicated, including the maximum that you should specify, which is indicated by this blue mark. However, you can just type it in. Let's say we want to allocate 512 megs of memory, then 512 megs of memory will be subtracted from the operating system's total amount of memory when we start the virtual host. However, this is the maximum. The blue triangle represents the maximum amount of memory that we should allocate. And if you drag the bar to that area, you'll see it's in the vicinity of 2 gigabytes, and the system has about 2.5 gigabytes. So in other words, it always encourages you to leave space for the host operating system. There are minimums, maximums, and recommended triangles. The green represents recommended. Just click on it, and it takes you there. Click on the yellow, and it takes you to the minimum, which they suggest is 32 megabytes. Recommended, however, is 256. But we want more. The more random access memory made available, the faster the virtual guest will perform. Whether or not you want the virtual guest to have a floppy drive is a separate issue. We'll remove it, as there is no floppy drive in the system. Let's click on OK to commit the changes, and now we have the profile. Now there are other things you can do with the virtual machine. If you edit it, you can click on Add to add to the pool of resources other devices such as sound, another Ethernet adapter, USB serial, the different types of ports that you're accustomed to finding on a standard PC. VMware creates a software-based PC. There are options over to the right, such as the name, which can be changed, and the type of OS, and the directory. So even after you've installed the operating system, you can redirect the OS to somewhere else on your system, either manually via the shell, and then update your VMware configuration by redirecting the working directory, or via the working directory icon or option using the browse icon within the VMware setting. Power controls. Green is power on, red is power off for this particular host. Whether or not you want to take snapshots, the permissions of the virtual machine, the startup and shutdown, whether or not the virtual machine should be started whenever the system starts. We can go ahead and set that now, power it on. So let's say we reboot the host system. So long as this is set, the on-host startup is set to power on, then the virtual guest will be started. And conversely, on host shutdown, we should indicate, which is the default, to power off the virtual machine, or you can shut it down, either or. Power off just shuts it off, just like shutdown would. And there are some advanced options. Disable acceleration, run with debugging information, which impedes performance negatively. disable memory page trimming, and other settings to help you in the event that you're troubleshooting poor performance. So let's click on OK, and we've got our settings. And now we're ready to power on the virtual machine and proceed with installation. The CD-ROM drive is tied to the host system CD-ROM drive, which ultimately leads to the dev tree HDA, which is the first ATAPI connection. The configuration file for this host is located beneath VMware 1 Virtual Machines RH5 Instance 1, and it's named rh5instance1.vmx, so this is the config file. Let's power it on, and you'll see that it starts just like a PC. Instead of Dell or Phoenix or some other BIOS information, we see VMware. Here's a startup screen. We can interact with the boot menu. For example, we mentioned that there are multiple options. If you press F2, it takes you into the options submenu where you can interact with it. And by the way, to enable your keyboard within this interface, just click on the screen, anywhere in the screen, which will cause the keystrokes to be transmitted to the virtual machine. Here's some installer options. If you want to disable hardware probing in the event that you're unable to install Red Hat Enterprise Linux because there's some sort of obscure hardware problem or obscure hardware causing installation to fail, you'd type Linux space no probe. If you'd like to test the media, Linux space media check, although we're prompted momentarily to check the media anyway. To enable rescue mode, you can type Linux space rescue or press F5. If you have a driver disk, let's say again you have obscure or not widely supported hardware, but you do have a Linux driver disk, perhaps you've downloaded from the manufacturer. By typing Linux space DD, the Red Hat installer will prompt you at some point for the disk so that it can read the additional drivers. To prompt for the use of other installation methods, for example, such as from the network, you can type Linux ask method. So again, this will prompt you. So for example, if you boot from a CD but want to reference, let's say from CD number 1 of 5, but want to reference the media on the wire, perhaps you have it served by an Apache or IIS web server, you can boot from the first of 5 CDs, but type Linux space ask method and then interact and proceed with a network-based install. That way you're not prompted to insert the distinct disks. If you have an installer update disk, something provided by Red Hat, then you type Linux space updates and provide that updated disk. And if you'd like to test the memory, just type in memtest86. To return to the main menu, press escape, and this will return you to the first screen. There are other options, or even F1 that is. There are other options. F3 provides you with some general information, tells you you're now ready to begin, and it tells you if you have problems with the graphical installer, you can set resolution. By default, the graphical installer defaults to 800 by 600, but if it's too big or too small, you can adjust it by indicating Linux space resolution equals, such as 640 by 480, which will cause the system to start in 640 by 480. So for example, Linux resolution equals 640 by 480. Since our overall resolution is 800 by 600, 640 by 480 will fit within our space, will cause the installation process to proceed at 680 or 640 by 480. Press enter, and this will begin the initialization of hardware, which includes the detection of the CPUs, the amount of memory, the attached storage, the setup of an initial RAM disk, and the loading of various modules to support various storage controllers. Again, a lot of what Linux does, regardless of distribution, when it starts initially, is to load drivers that are widely used, such as SCSI or RAID arrays for Dell, HP, and other IBM types of computers, and others. We'll skip the media check by pressing tab or left or right arrow keys to get back to the skip section. Press enter, and this will take us forward. Anaconda is being run, and Anaconda will help to detect, or will detect, the connected hardware. It found the video card to be a VMware Inc., so it knows that it's being installed on a VMware Super VGA card, which again is an emulation. And now it'll propel us into the graphical environment. There you see our X pointer followed by a little square pointer beneath it, which is the VMware Ultimate pointer, which allows us to interact with the interface. Now in this case, the installation process has kicked us out. What that means is the graphical support isn't working. So ideally we should install in text mode. So let's power on and try it again. And it's likely to happen in your environment as well. So if you find that you're ejected from the installation process, then boot up and execute Linux text. Or navigate to Options with F2 and you'll see the options for various settings. But Linux-based text will boot us in a text-based mode, which operates at 720 by 480 or 720 by 400, somewhere in that area. So again, our hardware is being detected. We'll be prompted for the media check momentarily, and we should bypass the graphical installer momentarily. Those are some generic drivers such as a TAPI. We'll skip the media check, and a Conda's being run again, and we should be up shortly in text mode with similar options, just non-graphical mode, of course. And there it sees the VMware Super VGA PCI display adapter, but now we're in text-based mode. So again, whether or not you're installing on VMware, if for some reason you're ejected or an error is thrown or you're rebooted inadvertently during the installation process, it could be related to the lack of support for your graphics card, and as a result you may want to type Linux-based text to enter text-based mode. Sometimes you won't know, like in our case, until you try it, whereas installing Debian on this version of VMware doesn't throw such an error. Now we're just navigating through the options here that we saw earlier. We'll skip entering the installation number. And of course it tells us that we won't get access to the updates, and we'll tell it we'd like to initialize this drive, so let's go ahead. This will create the default layout later on, and it sees that it's an 8 gig partition. So we'll remove Linux partitions. There are no partitions, so we'll just have it create the default layout. You've chosen to remove. Are you sure? Of course we're sure. There's nothing there anyway. Again, the 8 gigs pertain to the space we saw earlier. So review and modify partition layout. If we indicate yes, it tells us what it wants to do. It's going to create a logical volume. Again, for those of you studying for the RHCE, you have to know how to create logical volumes. We look at logical volumes later on, as we did with the Debian edition and SUSE Enterprise edition of Linux CBT. But the default partition that's created for general usage for the root file system is based on logical volumes. The swap file system also is a logical volume. However, the boot file system where the kernel is located is not a logical volume. Neither is the swap, or the swap partition is, but the boot partition is not. So the boot partition is not a logical volume. We do have the ability here to create RAID partitions. We'll show you how to do that later on as well. We want the grub bootloader. Electing to not install the grub bootloader would lead to difficulty booting the system unless we have a boot CD or floppy. Enter OK, and we don't need to pass any options to the kernel to get this system to start. You can protect your grub menu by indicating a password, which will prompt the user for a password, and this is the entry that will be made into the menu file that grub uses and presents to the user whenever the system boots. Let's enter OK. We want to install the bootloader in the master boot record so that it boots. Again, you'd not select this option if for some reason you're dual booting or have multiple operating systems and grub will not be the default bootloader on the system. But since it is the lone operating system, we'll install the bootloader grub into the master boot record. the small section of the disk, 512 bytes, that the BIOS references immediately after it has passed your configuration of your hardware. It asks if we'd like to configure ETH0. We'll indicate yes. We want it to be activated on boot. It's detected as an AMD, and this is the interface, PCNet32. So we'll indicate, and we want IPv4 and IPv6 support. For now, we'll accept DHCP. We'll change it later on, since there is a DHCP server. As far as IPv6 is concerned, we'll leave the configuration as it is so that the Cisco router provides the prefix information. That's what's meant by automatic neighbor discovery. IPv6 systems search for neighbors on their subnet, and usually the router, if configured for IPv6, will provide the prefix information, which will allow the host to self-configure. And here it says if your system's part of a larger network where host names are assigned by DHCP, then select DHCP. Our host names in this case are not assigned by DHCP. They could be. In that case, we'd set up a reservation matching the MAC address of this VMware instance to the host name indicated. But we don't have such a table configured, so we'll name the host linuxcbt serve3.linuxcbt.internal. And this is the fully qualified domain name. Enter OK. And the system clock in this case does not use UTC. So we'll turn it off. The time zone is correct, so we'll enter to continue. As you can see, the settings that we're driving through here, or moving through rather quickly, are identical to what we saw in the GUI base installation moments ago. So we can go through them very quickly. We'll install software development and web server, and we'll elect not to customize the software selection in the interest of saving time. Now, dependencies will be checked to be sure that we have everything we need so that there are no broken packages or broken applications. And once all the dependencies have been met, we'll move on to the next step in the installation. Now, just like when we installed moments ago in graphical mode on the server, the PowerEdge server, using the CDs 1 through 3 of 5, there are multiple consoles or identical consoles available minus the graphical console. You can access those consoles using Control-Alt F1 through F5. The consoles provide invaluable information regarding the detection of hardware and the installation of software. So there's one screen which keeps a running log of what's being installed, what's being done to the system, including individual commands that are being executed by the installer. There's another screen which is responsible for hardware detection, the status of hardware detection, which includes the processors, memory, storage, network, audio, CD-ROMs, DVD drives, writers, you name it. Anything that's attached to your system that Linux supports or even doesn't support will be enumerated on the hardware detection screen and can provide invaluable information to you in the event that there's a problem. And even if there's no problem, just for your own edification. So we're at the halfway point with the dependencies. Now, you will notice that on VMware, the performance is a little bit slower than a native computer, and in some cases it may be much, much slower, depending on the utilization of the system. Now remember, when you install within a VMware environment, you're making use of emulation. So it's not a real computer, it's a software-presented computer. So although it's fast, it's not as fast, and will never be as fast as a comparable physical computer. However, it may be fast enough for your intents and purposes. For example, for simple services like DHCP and DNS, NTP and FTP, SSH, Telnet, and others, it may make sense to install those systems within a contained VMware setting on one physical system, whereas more complex, taxing systems like web, databases, and application servers will benefit from dedicated physical hardware. Or you can build your systems vertically by building bigger systems with more CPUs, more hard drives, more and faster hard drives, great network connectivity, and simply cut up the resources using software like VMware. The version of VMware that we're using is the Server Edition, which is free. It's open source, and you can download it and use it within your environment. But if you want a full management framework, you'll need to look at the ESX or full VMware management suite of applications. Now, just like before, the installation process will create an install.log file in root, which will serve as our proof as to what the installation program did and didn't do. It will also create a kickstart file, anaconda-ks.cfg, in the /root directory, which can be used to replicate this installation on this or other machines. Because the file system is much smaller than the server that we installed on, which had to allocate about 100 gigabytes for the root file system, this has been formatted much, much quicker. Again, the allocation of file systems using ext3, riser, and other file system types like JFS, XFS, etc. tends to take a good amount of time. Formatting also takes some time, so you just have to wait it out. Now the image is being transferred. It'll be on the hard drive momentarily, at which point the files will begin copying, as you can see here in the background. So this installation is proceeding much, much faster. Now this system isn't considerably faster than the Dell PowerEdge server. Each processor is about 200 megahertz faster. That's it. Not much of a difference. They're comparable, in fact. At any time, you can interact with the virtual machines by selecting options that are not grayed out, such as power off, suspend, etc. up top. You can also navigate back to your shell and other programs while the virtual machine is installed. Again, the files haven't been copied yet, so it's going to take a while, and we're going to catch up to it at the beginning, middle, and end sections and just ensure that the system reboots into a full environment. Now it's preparing the transaction from installation source, ensuring that the disk has the options or the different packages that are necessary to fulfill our options. And now you see the packages being copied. The G library, or glibc that is, C library. We get an ETA below. So the estimation is roughly 1 minute, or 1 hour, 9 minutes, 27 seconds for the full installation, which seems about right, but it's variable. It's subject to change. In total, we'll install just under 950 packages. And again, there are thousands included with this release of Red Hat Enterprise, just as you'd find with other Linux distros. So now we're down to 14 minutes as opposed to over an hour, and this is more like it. So these packages will be copied very quickly off the DVD. We won't be prompted for additional media since we have everything in one place. Again, when you sign up for a subscription or for a trial at redhat.com, you'll be provided with login access and the ability to download the CDs and or DVDs for the latest release of Red Hat Enterprise, as well as for older releases such as 2.1, 3, and 4, which are still used quite heavily in the wild. So the current ETA is 13 minutes. We'll catch up to it at roughly the halfway point and then go through the full reboot. So now we're ending the installation at 96%. We should be ready momentarily to reboot and enter the new system. Now, if we have problems launching in graphical mode, we can always change the run level to the text mode of run level 3, which will ensure that all background services run or while avoiding the problems associated with starting up in a graphical environment within VMware. Again, we're likely to experience this sort of problem even on a native system, as the kernel and the installer doesn't always detect the connected hardware. So it's just a fact of life when working with Linux, but when installing a server, it's less important or a non-issue, as the purpose of the server is to serve or to provide background services and not necessarily a desktop. So just like in the graphical mode, performing a post-install configuration is taking place. And again, the consoles are available which provide information, and install.log is made available in root's home directory beneath /root, so that once you're up and running, you can peruse it to determine if there are problems or just to see what was detected and what transpired on your system. So the installation is complete. We should remove any media and reboot the system to get it to boot into the operating system. So let's go ahead and eject the media. And if you're following along, you would have seen that the installer has already ejected the media for you. So we'll enter to reboot, and the system will be rebooted momentarily. These are some of the items we didn't see when we were installing from the console, such as the unmount of the file system. And here's the boot menu, at which point we can interact with it by pressing enter, but it prompts for only a few seconds, so you have to interact with it very quickly. ACPI, 2 logical volumes found, one for swap, the other for the root file system. If you recall, we discussed that during installation. You can interact with the installation at this point by pressing I, and you can use it to interact with the loading of each of the services, but you have to do it at that point. So in other words, you have to do it very quickly. The file systems have come up, including boot and the root file system. It entered run level number 3, which means it should load different services. As you can see, IP6 tables, firewall rules were loaded. SSH version 1 and 2 RSA and DSA keys are being generated or have been generated. Cups started, SendMail, the default SMTP application, and here we are again with text, or a text-based interface. So select the item that you wish to modify. You can pick whichever option you like, such as the firewall configuration. We'll tell it to disable the firewall like we did previously. SE Linux will tell it to use the disabled mode, which means it will simply complain if there are problems. There are other options: network configuration, which we have set to DHCP, various system services, the time zone configuration, enter to run the tool. It's set to America, New York, which was determined during the installation. Keyboard configuration, authentication, whether or not you want to authenticate against a remote source. Now our system's up and running. There it is. We have a login prompt. We can log in. Let's say as a user root, and we have a shell. If we type TTY, you'll see that we're on the first teletype terminal. We can interact with the other terminals using Control-Alt F1 through F6. We can take a look at the disks or the file system by using df-h, where we see that of the 8 gigabytes, 6.7 were allocated to the root file system, 100 megabytes were allocated to the boot file system, TempFS has 252 megabytes, and the swap file system has its item. Let's just list here with swap on. And it has its items list, swap on-s, that is. So the swap file system is set to be at about a gigabyte, size being 104,856.8 in kilobytes, of course. So we're up and running. Top will tell us what's there and how much of the CPU is being utilized. Netstat will tell us what services are bound, which includes ports 910 and 111 for RPC services, 631 for cups, 25 for SMTP. NTLP will tell us the programs that are attached to those ports, SSH being on port 22, and we're up ready to access connection. SendMail is listening on port 25, and Netstat NUL will return any UDP listeners, including DHCP, cups, among others. And an ifconfig will tell us the configuration. As you can see, we got an IP address of .199 from the DHCP server. We should be able to ping out, sending 3 packets to the default gateway. and it responds, indicating that this system is properly connected to the network. The IP version 6 prefix was also configured, 6-4 prefix of 2002-4687 DB25. We're on the third network, followed by the embedded MAC address of the local system, constituting a 128-bit unique IPv6 address. So IPv6 is configured, IPv4 is configured, our interface is up and running, we can communicate, and we can use the system in run level 3. By the way, if we type run level, it'll tell us what run level we're in. We're in 3 because we were unable to configure the X environment during installation. So rather than attempt to enter a misconfigured X environment, the Red Hat installer simply defaults to run level number 3. But that's it. We have a new host up and running. Host name tells us that we can exit. It returns us to TTY1. And in this case, it's Enterprise Linux Server Release 5.1. The latest patch is available, and it's using the 2.6.18 kernel. So we're up and running. This is a VMware instance, which is independent of everything else. We can use the system, access it from the wire, all without using an additional physical system. Now, we want to look at other installation methods, including Anaconda and network-based installations. So we'll be focusing on those items.